All right, I'm going to go to example 2. Example 2, this is kind of fun. We're going to look at this again, and we're going to see basically that this has technically 3 denominators. Technically, you see this 2 over here? This 2 technically has a 1 underneath it. Now, I'm not going to sit here and keep writing over and over 1 times 4, 1 times 5. I'm not going to keep adding that 1 for this stuff because, like, look, 1 times 4 is 4, 1 times 5 is 5. I'm talking about that because this common denominator 1, yes, it's there. Do I really need to add a 1 next to this where it says 1 times x minus 2? It's just redundant information. But I'm letting you know that there is, in fact, a fraction right here into this 2. So, and it's just in 1 in there. So what I'm going to do is, I'm not going to ignore the reality of that, but we don't have to add it. Again, 4 is the same thing as 4 times 1. So why am I writing out times 1? And if that doesn't make sense at this point in life, y'all, like, good luck. Here we go. I'm going to go ahead and draw out the fraction bars as best as I can. I want to make bigger rooms for my fraction bars. That's what I want to do. And I'm going to copy down the original problem. The original problem has x right here. It has x plus 1 right here. And then over here it has x minus 2. And then it has x on top. And then over here it has a 2. And again, I'm not going to write the 1 because it's redundant information. I don't need to do that. Now, the best way to find the common denominator is to multiply every denominator together. X plus 1 times x minus 2 times 1. And again, it doesn't matter. We're not writing the 1. So what am I going to do now? I'm going to go find the common denominator. Check out what's missing over here. X minus 2 is missing. But if I put it on bottom, I got to put it on top. Check out over here. I have x minus 2. But I don't have x plus 1, so I'm going to write my x plus 1 right here. Here we go, my x plus 1 right here. Now I'm going to go over here, and I'm going to see this 2 is missing both of them. So now I'm going to have in there x minus 2, x plus 1, and I'm going to put that up here. X minus 2, x plus 1. Now I'm going to check to make sure my denominators all match. Do they all match? Yes, they do. The denominators all match. Before I scratch it out, I'm going to figure out what I can solve and what I can't solve here. So the denominator is x plus 1 and x minus 2. So I'm going to set x plus 1 equal to 0, which means x cannot equal negative 1, because we do not want that in the bottom. Now I have this x minus 2. I need to figure out as well, too. X minus 2 equals 0. We're going to go ahead and add that to both sides. So x cannot equal 2. All I did here was look at the denominator and pull out the factors and solve. If I were to plug in a negative 1 into here, it would make this go 0. If I were to plug a 2 in here, it would make this turn into 0. And can you see this up here? If I plugged in a negative 1 plus 1, we don't want zeros in the denominator. That's what I'm trying to say. So once you figured out what it can't equal, now you can basically, with all this stuff here, you can come through and just scratch out your denominator. You can kind of, in quotations, ignore it. But look what's going to happen on this one. This is where the complication happening. This is where the information starts getting more and more difficult. Because what happens is, check it out. I'm going to introduce x squares. So I'm going to multiply x times x right here and get x squared. X times negative 2 is negative 2x. Then I'm going to have x times x, and that's a positive because there's a plus x. So then I have x squared here. Then this x times this one is just x, 1x for those. Now check this one out here. This is going to require some fun little stuff here. So I end up with, I'm going to do it on the top here. I'm going to do it over here so I don't waste my space down here. X times x is x squared, and I'm just doing the blue ones right now. X times x, so I go like here, x times x, then x times 1. So that's plus x. Then I'm going to go over here and do my negative 2. So that's negative 2x. And then negative 2 times 1 is negative 2. And then, here's the fun part. I did all of these, right? Let's count them. 1, 2, 3, 4. I did 4 multiplication problems here. But look, y'all, it still requires me to multiply by this 2 right here. So I still have to, when I'm done with this, multiply everything by 2 in here. So here I go. I'm going to go ahead and multiply everything by 2 in here. 2x squared. And again, there's the 2. That's going to turn into 2x. Negative 2 times 2 is negative 4x. And then negative 2 times 2 is negative 4 as well, too. Phew. See all this and this a lot, basically? The answer is yes. This is a lot. So let's go ahead and put this stuff together. X squared plus x squared is 2x squared. Negative 2x plus x is just negative x, equal to 2x squared stays here. 2x minus 4x is negative 2x. And then we have minus 4. Okay. Once I see that I have x squared, that should tell you to put everything on one side. Put the letters on one side and 0 and everything else on the other side. Or put 0 on the other side, I mean. So let's move this over. And let's see. Here's a cool little thing I noticed. Look what happens when I do my 2x squared. If I were to move it on both sides, what ends up happening is it ends up canceling out. So this 2x squared ends up canceling itself out on both sides, which is kind of nice. Now all I have left is moving over this stuff. So I'm going to move this 2x over. I'm going to move this 2x over on both sides. Negative 1x plus 2 gives you a positive x. So x is equal to, and then what's left over when I do this? Negative 4. I know this is hard to follow, but it's not that bad when you let it like sink in that you've already done factoring before. You've done like equation work before. It's not so bad. So that is example 2.